Okay, so let's do this. So discuss when the law of sines versus the law of cosines are used. So the law of cosines are used when we have triangles which are not 90 degrees, not 90 degrees, not 90 degrees, or oblique, not 90 degrees or oblique. Both of these are used if they're not 90 degrees or oblique and we are asked to find missing angles or sides. But some values have to be given for both law of cosines and law of sines. So for law of cosines, you need to be either given 3 sides, also known as SSS, or 2 sides with the angle included. So what that looks like is that if you're given a triangle, you're given the sides, and these are just imaginary sides. I don't know if they're actually true. So 10, 8 probably are 10, 8, 7. Or you have 10 and 7, but there's an angle of 40 degrees over here. And then law of sines are used when you're given 2 angles and a side, which is not included, and a angle and a side which is included. Also, law of sines is used when you have SSA, but that's a little different because this is the ambiguous case. So the angle, so what this looks like, angle, side, is that you have 2 angles given, so angle. So let's say this is 30, this is 40 degrees. But then, instead of this side given, this side or this side is given to us. And this looks like right here if the side included between the 30 and 40 are given. Okay, now solve the triangles with the measurements below. So let's draw our triangle, which is A, B, and C. So A, B, C, and we have an angle of 75 degrees at A. So we're given an angle, meaning, and we're given 2 sides. We're given the side of B, which is going to be opposite to the angle of B, so that's going to be 4. And it's going to be opposite to the angle of C, so it's going to be 10. So this is side, angle, side, meaning we're going to use the law of cosines. Okay, so as I mentioned right here. So law of cosine says that the side not given to us, so let's do, this A is not given to us. So it says A squared is equal to B squared plus C squared minus 2A, not in this case, BC, because these are the sides right here, BC, times the cosine of the angle A. And now we just plug in values, so we get A squared just stays A squared because we were trying to find that. B squared is going to be 4 squared, or 16, plus 100 minus 2 times 40, because B times C is 40. And then the cosine of 75. So we can get A squared is equal to 116 minus 80 times, or let's do minus 80 times the cosine of 75. So what does that get us? So if I plug it into my calculator, 116 minus 80 cosine of 75. Let me make sure my parentheses are correct. I get a squared is equal to a 95.2944 dot dot dot. And now I'm gonna take the square root, and the square root of my answer gives me approximately, and we have to round to the thousands because it said in the description, so 9.762. And that's our solve the triangle. Okay, and that's our side of A. So that's A. Right, now that we have A, we can figure out all of this triangle, because now we have side, side, side. Meaning we can figure out the angles. So let me shorten all of this work. So right here, and our A is goes over there. So that's one value right here. Now our second value, we have to find this value and then use this value to find this value. And then we have everything. So let's find the angle measure of B. So if we're finding this, right? If we're finding, let's label that as X. And we have all the sides. We have to make sure that, so this is how the equation is going to look. It's going to look B squared is equal to A squared plus C squared minus 2AC times the cosine of B, because we're trying to find B. So B squared is 16. A squared is going to be this number right here, which I have in my calculator right now. So let's just put 9.762, and I'm not going to use I'm going to use this number, but it's going to be a more exact version in my calculator. So 9.762 squared plus C squared, or C squared is basically 100, minus 2AC minus 2 times 9.762 times 10 times the cosine of B. So now that we have all of that, let's see. So let's plug this all into my calculator. Or we can okay, now that we have that, we can do 16 minus 100 minus the square root of 9.62 squared is equal to negative 2 times 9.762 times 10 times cosine of B. Okay. Now that we have that, we can also put the cosine of B is equal to 16 minus 100 minus 9.762 squared 9.762 squared, so all over negative 2 times 9.762 times 10. So now that we have all of that, let me plug it into my calculator. That's going to take a second. So 16 minus 100 minus parentheses 9.762, or in this case my answer, all over -2 times my answer times 10. Let me double check so I don't make any mistakes. And we enter. And we get this value, but that's not what b is equal to. The measure of angle b is going to equal to the inverse cosine of b, because we're trying to cancel out this cosine, and we can do that by taking the inverse. So we take the inverse of my answer on my calculator, and I get the measure of angle b is approximately equal to 23.316 degrees. And now that we have both of our answers right here, we have measure of angle B and the side length of A, and so let me just leave it like that, right? Now we have one value, we have two values, we have three values, and then we found the fourth and fifth value. Now if you have to find the sixth value. To find the sixth value, we can just say that a triangle, all the three angles of a triangle add up to be 180. So 75 plus my answer, or 23.316 plus, let's see, what's the side I'm missing? Measure of angle C, right? So I'm missing C is equal to 180. So now we just solve, and we get 75 plus my answer on my calculator. Answer, and then we get, so 180 minus my answer. So we get measure of angle C, I just solved this on my calculator, is equal to 81.684 degrees. And now we have solved for the triangle in its entirety. Oh, and that's approximate value. So approximate. There we go. Okay, so given information, circle 1, and law used. Okay, so as I mentioned, if we're given SAS, the law we use is the law of cosines. And then, okay, let's say we're given SSS, the law we use is again the law of cosines. ASA, and we use LOS, and AAS, we again use LOS. So let me just color code that so it's, I don't know what this question is asking, but I hope I'm doing it right. I think it's asking this. So SAS and SSS goes to law of cosines right there. And then ASA and AAS goes to the law of sines right there. Okay, now I'm pretty sure the next one should be a law of sines because, okay, so we are given three values. So we're given two sides. Okay, so we're asked for the same question, given information. Oh, I get it. So this is asking for, if you're given this information, what are we using? So as I told you, we're going to be using SAS, and that's the law of cosines. Now, if we're given this information, what are we going to be using? So we have, let's draw our triangle. So because that, let's draw our triangle. So we have A, then angle A, then we have B, then angle B, and then we have big C, and then C. So we get 34 degrees right here, because that's the measure of angle A. Then we get A is equal to 7 right there. And then we get, let's see, then we get B is equal to 9. So, okay, so I'm back. So, as we know, that's equal to 9. So, if we're given that information, do we have SAS? So, let's see. SAS, so let me see if I plugged in all of it right. SAS would be if this was right here, and that's not the case. Do we have SSS? No, we don't know all three sides. Do we have two angles? No, we do not have two angles, so we cannot use either of these. So given this information, what are we going to use? So I see how you made space for us to add our own. So this is going to be SSA, which is going to be the ambiguous case. And if it's SSA right here, we still use the law of signs. It works a little differently. So we're given this information right here. So I'm just going to solve for all of the values because I don't know if you're supposed to do that, but I'm still going to do it. So we're given this information. Let's make a perfect triangle. We're given that information, right? We know that A is 34. So let's make A right here, 34. Then we have given the opposite angle, our opposite side, so 7. And then we're given B, which let's make right here. Let's do that's B. And then that's C, and this is capital, or the angle C, and this is the silent C. Okay, now we're given that, right? If we're given that, you're still going to use the law of signs to find our all the values. But this time, we get to use a little bit of trig. So, to figure out how many different triangles can be made from this particular triangle, we drop a hypotenuse, and we drop a hypotenuse right there, and then we solve for this side, which we call h. And depending on what h is, this can be a imaginary or have no solutions. It can have one solution, or there can only be one of these triangles, or there can be two of these triangles. So to do that, first we have to find our h, and to find h, we can take the sine of 34 is equal to h over 9. So 9 sine of 34 is equal to h. So 9 sine of 34 is 5. Right? Now, 5 point something, 5.032. So 5.032. Now what this tells me is that since this value, h, is less than this value right here, but, okay, so if h is less than this value right here, and this value right here is less than this value right here, we have two solutions. Because since this is 7, we can also have, without changing any of the requirements given to us by this, we can also have a triangle like this, meaning there are two solutions to this. So let's find both of them. So to do that, we first have to, okay, so we can use the law of sine. So sine of 34 over 7 is equal to, we are given one more value, 9. So 9 over the sine of b. So we can find the measure of angle b. And to do that, we do 9. So we cross multiply. So we get 9 sine of 34. 9 sine of 34 and then we will divide by 7. So 9, 7, 34 divided by 7 is 7, and then we'll take the inverse sign because we're trying to cancel out this sign right here. So the inverse sign of my answer is 45, meaning, or 45 point something. So B, measure of angle B, is equal to 45.968 degrees. There we go. And then to find our other angle, we have to realize that since this has to be 7, this triangle right here will form an isosceles triangle. So if it's an isosceles triangle, the base angle, so meaning B, is equal to this angle. So if that's equal to that angle, so the inner angle on this side is going to be 180 minus the measure of angle B. So our other value, or our other triangle, can have, so our triangle like this with B right here will have a measure of angle B, which is going to be 180 minus, let's see, minus answer. So there we have 134, meaning this is 134.031 degrees. And now we can use this to find every single value in both of the triangles. But usually we're just supposed to find the B. So I'm just going to leave it like that. But we can still go and use the law of sine to find. Oh, and the law of sine, I forgot to tell you this, but it's just a proportion which says the sine of angle B over side length B is equal to sine of angle A over side length A, and sine of angle, C over side length C. That's what the sign says. Okay. Now, discuss the ambiguous case. So we just did that. So, and draw 2 pictures to represent the scenario. Okay. So 2 pictures to represent the scenario, right? So I already showed you an example with 2 solutions because it gave us this, right? And let me just check if it actually was an ambiguous case or I just messed up. So A is 7, B is 9. Then the angle at A is 34, and we do not have an included angle, or is it we don't have 2 angles and the angle is not included? Okay, yeah, that was an ambiguous case. Okay, cool. So now that we have done all of that, let's draw the ambiguous case. So there are 6 examples of the ambiguous case, but it's only asking us to draw 2, so we're just going to do that. So one of them is going to be something like I draw above, but I'm not going to draw it again because I already did it. So we're going to draw something which has no solutions. So no solutions. Let's say this is 1, right? And no solution. Oh, let's say this is, yeah, that's 1. And then we have a triangle right here. And it gives us a side length that this right here is a 0.25, right? And this right here is 30. So now we drop the altitude of this triangle to find this value right here. And this value will tell us that we have no solution. So this was 30 degrees and this is 90 degrees. So if we have sine of 30 is equal to h over 1, right? Because opposite over hypotenuse. So basically, sine of 30 is 1/2, so h is equal to 1/2. Now that we have that, and 1/2 is 0.5. So 0.25 is less than, so we have that h is greater than this value, which let's just say this is big B, and this is little b, this is A, and this was, well, that's no side. So, and that is no solutions. Now let me tell you the reason why that is no solutions. The reason why that is no solutions, because 0.5 is the minimum value any side has to be. So this side has to be to reach this end right here, because 0.5 is at 90 degrees. This side length has to be more. Any side length beside 90 degrees has to be more than 0.5. Any side length which has to be more. So that's the reason that has no solutions or zero solutions, or this is an imaginary triangle, meaning this can't be made. That's an ambiguous case. And then and this is ambiguous case because this is SSA. We have a side given to us, we have a side given to us, and we have a non-included angle. And another example would be when there is one solution. So let's draw the same thing, but this time this is 1, this is 30, right? And we're given that. But instead this time, let's make this 2. Correct? If that's 2, we already know that this is 1/2 because we just found that. So that's 1/2. So meaning this can reach the end and we can form a triangle. But this cannot have 2 values because h is not greater. H is not less. Wait. Okay, so h is less than 2, but 2 is not less than 1. So meaning we cannot have a value like this. Meaning this will have one solution. Because to make this side length 2, you'll have to keep going and going to the right instead of the left. Because in the left, it's not going to reach 2. So, yeah, that's the ambiguous case, and that's everything.